Bum 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 ba-dum ba-dum ba-dum. Ba-dum bum ba-dum bum. Ba-dum bum ba-dum. Okay. Well, welcome back. We're doing homework again. I'm just gonna jump in. No need to explain anything. We're just going through this. I'm just live streaming so that I have a reason to get it done. Okay. So plug 0 into cosine, right? Cosine of 0 is 1, so that's just going to be 1 times 5, 1 times 3, so this equals 5 over 3. Let me put that in, double check, 5 over 3, and boom, bang, bomb, it's good. All right, number 12. Whoa, that's a 3. Number 12. The limit as x approaches 1 from the right side of natural log of x to the 8th minus 1 minus ln of x to the 5th minus 1. Okay, let's see. What do we want to do here? I'm gonna graph it on my graphing calculator real quick. Hold on. Okay, ln of x to the 8th minus 1 minus ln of x to the 5th minus 1. Okay, let's see what that graph looks like. Okay, so it's like, let me show you what the graph looks like. The graph is, wait, let's color this like that. And then we have like 1 right there. And then the graph looks something like that. And it's, I believe the domain is 1 to infinity. Okay, but what needs to happen is plug 1 in and see what we get. So this is going to be the natural log of 0 minus the natural log of 0. And the natural log of 0, in case anybody does not know, is impossible. So instead of doing this, well, hold on. Okay, we can change this up a little. So this is actually the natural log of x to the 8th minus 1 over x to the 5th minus 1, I believe. So in order to find the derivative of this, we're going to have to go with like the outside function and the inside function. So the inside function, the derivative, I don't want to do this. Well, okay, maybe instead of changing it like that, maybe we can just take the derivative as it's like this already. So let's go outside function, derivative is 8x to the 7th. and then no, that's the inside derivative. Outside derivative is 1 over that. So because 1 times that, it's just that, you know. We're then going to put the bottom here. Minus 5x to the 4th over x to the 5th minus 1. We could probably combine like terms here if we really want. Because at the moment, if we plug 1 in, it's still going to be divided by 0. And that's not good. So let's combine terms and such. So it'll be 8x to the 7th times x to the 5th minus 1 minus 5x to the 4th times x to the 8th minus 1 over x to the 8th minus 1 times x to the 5th minus 1. Okay. And we need to just be sure that we minus everything over there. Let's just simplify this a little bit. And by simplify, I mean FOIL everything. So we'll do 8x to the 12th minus 8x to the 7th minus 5x to the 12th plus, oh, no, that's still a minus for now, 5x to the 4th. So, we know the bottom, right? I'm not going to change the bottom for now. This becomes, these are like terms with the x to the 12th, so we can change that to 3x to the 12th. And then those are not like terms, so this is just going to be minus 8x to the 7th plus 5x to the 4th over, and then I guess we can bring that back in. Okay, let's try plugging in 1 to this. And I'm kind of wondering, did I like make this super complicated, like way more than it needed to be now? I probably did. I wonder if it would have been better to do the other way. I kind of want to try the other way, just for funsies. Here, we'll do it in a different color, green. Okay. Then we need to find the derivative of this. And so to start, derivative of ln is the inverse, you know. So it's going to be x to the 5th minus 1 over x to the 8th minus 1 times the derivative of it, which is, oh, this is going to be a whole other mess. So we'll do x to the 5th minus 1 times the derivative of this one, which is 8x to the 7th, and then minus x to the 8th minus 1 times the derivative of the other function. Should probably zoom in here a little. to the fourth over, well, hold on, before I do the over part, let's see if I can simplify this anymore. Any like terms in here? We'll probably get the same like terms we had over there, huh? So 8x to the 12th minus 8x to the 7th minus 5x to the 12th plus 5x to the 4th. And then combining, yep, 3x to the 12th minus 8x to the 7th plus 5x to the 4th. Whoa. What in the world? Okay. All of that is over x to the 5th minus 1 squared. Okay. It's a little bit less messy-ish. Well, okay, maybe not. Anyways, we have to bring it down here and times it. So it's gonna be x to the 5th minus 1 times all of this, 3x to the 12th minus 8x to the 7th plus 5x to the 4th over x to the 5th minus 1 squared. And interesting, because, well, hold on here. The way I did it over on the blue side came with the same answer in the numerator here and the denominator, but when I did it in the green, it added this. So now I'm wondering, which one's right? Oh, I do this so many times where I do things in a different way, and then I'm like, okay, now which way is the way I should have done it? Does anybody else ever get that? Or is it just me? Am I just crazy? I'm probably crazy, but whatever. Hold on. Okay. That's dumb. Okay. The question is asking, okay, maybe I should just try plugging in 1 and see what happens here. So if we plug in 1, we have 1 minus 1 over 1 minus 1 times all that mumbo jumbo, but because it's times that, it's still going to equal 0 over 0. You know? If we do that over here, I don't know, it'll wait, hold on, why am I acting like that's going to be really hard to do? It's just 3 minus 8 plus 5. So yeah, that's still 0 over 0 as well. So we need to find the next derivative Oh man, I don't wanna. I really want to know like which one was correct though. I think for now I'm just gonna go with this one because this one ended up being a little less complicated. And if it ends up being wrong, then we can come back and we've already started this one. So, question is, should I FOIL this? Oh, wait, it is the same thing. Because this one's squared. Oh, look at that. Wow. Yeah, it's the exact same thing. Okay. Cool. But we still need to find the derivative. So I think I should probably FOIL this because then it's a lot easier to find the derivative because there's no... Wait. Yeah. Because then we're using the rule, the Hospitals or whatever his name was. Okay. And I'm wondering, should I not have done the derivative in this manner? I don't know. We'll find out later, but let me FOIL this real quick. Okay, so this is going to be x, wait, to the 13th minus x to the 8th minus x to the 5th plus 1, right? And I'll just like do this, like this is what it actually is when it's FOILed. I don't even know. Okay, so let's find the derivative. That's going to be 36x to the 11th minus 56x to the 6th plus 20 times x to the 3rd over 13x to the 12th minus 9x to the 7th minus 5x to the 4th, and then that 1 goes away. Let's try and find it this way. So of course we're still plugging in 1, so these x's don't really matter. It's because it just becomes, you know, 0, like 36 minus 56 plus 20. But we know 20 plus 36 is 56, so the top is going to be 0. And the bottom, well, hold on, the bottom, maybe I did the bottom wrong. Hold on. 13 minus 5 should be 8. Hold on. Did I do something wrong? Is this supposed to be an 8? I think that's supposed to be an 8. Yeah, that's supposed to be an 8 right there. Okay. I read it as a 9. So that's 8. So that also equals 0. So we need to find the next derivative, which is going to be... Oh boy, this is going to be hefty. Hold on. I don't want to calculate that much. So, okay. I'm going to go this way. 396 times x to the 10th. I'm probably really blowing this out of the water, and it didn't need to be this complicated. let's see, 13 times 12. Oh, 13 times 12. That's 156 x to the 11th minus 56 x to the 6th minus 20 x to the 3rd. And this is going to be, pretty sure this is still going to be the same, because 60 plus 336 is 396, so that's, well, hold on. Wait, it actually, wait, I didn't add this one wrong, did I? One minus one minus, hold on a minute, hold on. Wait. 1 minus 1. Okay, yeah, that's still 0. Okay. Oh my goodness. And then this one should still be 0, right? I'm just trying to figure out if I'm throwing this overboard or whatever. Because according to this is 120. And then on the bottom we have 156 minus 56 minus 20, which is 80. And then that's going to be 12 over 8. And then divide that by 2. That's 6 over 4. So it's 3 over 2. 3 over 2. Okay. Let me see if that works. 3 over 2. No, it did not work. Huh. Okay. I'm gonna watch, well, no, they don't have a video. Dang it. I was going to watch their thing. Hold on a minute. Okay. I did something wrong here. What did I do wrong? Did I? 120 over 80. It's 3/2, yeah. I'm gonna try, well, hold on. Here's the, well, hold on. I'm thinking. Because, okay, if we were to, yeah, that becomes 0, that becomes 8, 8 times 0, 0, that becomes 0, so that's 0 over 0, yeah. Okay, yeah, yeah. That's 0 over 0. Then we found the derivative, and so okay, when we took the derivative here, we used the Hospitals or whatever the guy's name is. We use his rule where you just take the differential of the numerator, bring it over, differential of the denominator, take it over, and we didn't use the chain rule like we used up here. So, okay, I need some guidance on this one. Oh wait, no. Oh, interesting. So the I in the guy's name, it's actually an L. It's just that the font that the homework site is using makes it look like an I. So it's L'Hôpital's. Interesting. L'Hôpital. Oh, interesting. Okay. Hold on. let me show you what is happening here. So instead of doing all of this crazy mumbo jumbo stuff, I'm actually going to erase it all, even though it pains me to do so. I wish there was a way to make the eraser bigger on Adobe Acrobat. That would be very useful. But as far as I know, there's no way. So it's just this painful process of picking out all of the tiny debris of pen markings. And I take all of my notes using Adobe Acrobat. So I just wish that there were a few more customization things for the pen and the markup tool. Okay, all of that is gone. I think I need to even take it a step further. Just go all the way up here. I'll leave the red and the green just for, I don't know, memory's sake. Okay, that's dumb, but I'm just being lazy. I just don't want to touch it. Okay, so take the ln of x to the 8th minus 1 over x to the 5th minus 1, and then instead of taking the derivative of ln, just leave it and take the derivative of, or like use L'Hopital's rule on the inside for some reason. That is what this site is recommending. So that's going to be ln of 8x to the 7th over 5x to the 4th. And so we plug in 1, and that's just going to be ln of 8 over 5. I'm going to try putting that in and see if it works. ln of 8 over 5. And that's like way easier and should have been what I did at the very beginning. Okay, it took it. It liked that. Okay. It's nice when it's easy like that, but it sucks when I do all of that work and then erase it and do it this other way and it works better. You get what I'm saying? Okay, I'm gonna erase this part too, just this little piece, so we get a clean slate as we go on to number 13, which is the limit as t approaches 0 of e to the 2t power minus 1 over the sine of t. Okay. Well, if we plug in 0, that means it's going to be 1 minus 1 on the top, which is 0 over sine of 0 is 0, right? Sine 0, 0, yep. So that doesn't work, which means we need to use L'Hopital's rule. Okay, so we find the derivative, which interesting. Okay. I'm gonna show a little thing. This is just to help my brain work. So if we have the function e to the u and u equals the 2t, right? This is how they taught us to do it before. So you find the derivative of e to the u, and e to the u derivative is always just going to be e to the u. But then you have to times it by the derivative of the u, which is going to be 2 in this case. So this would equal 2 times e to the u. I think that's what it wants us to do. So that's what I'm going to do. So this is 2 times e to the 2t, and then 1 goes away, over cosine of t. That is not going to be. Okay, well, this goes, right. Plug in t, plug in 0. I'm getting flustered. Plug in 0 and we get e to the 0, which is 1. And then, so that'd be 2 over 1, because the cosine of 0 is 1, so it equals 2. Let me put that one in, see if it works. And it worked. Okay, great. 14. So we're looking for the limit as x approaches 0. And we have e to the 2x minus e to the negative 2x minus 4x over x minus sine x. Okay. If it's 0, then it's going to be 1 minus 1 minus 0 over 0 minus 0. So 0 over 0, can't have that, can we? So we're going to find the derivative, which is going to be 2 times e to the 2x plus 2 times e to the negative 2x minus 4 over 1 minus cosine x. Okay. So if we do that, then this is going to be 2 plus 2 minus 4 over 1 minus 1, which equals 0 over 0. Can't have that. So we'll find another derivative, which is going to be 4 times e to the 2x minus 4 times e to the negative 2x, and then that 4 is gone, over sine x. So this is going to be, once again, 0 over 0. So we'll find it again. This is going to be 8 times e to the 2x plus 4, 8 times e to the negative 2x over cosine x. And this will equal, well, if we put in our 0, then that's 16 over 1. So 16. 16, let's put it in, and boom, it accepted. Awesome. I think we're running out of page here, but it's fine. 15. We have the limit as x approaches 0 of the square root of 1 plus 8x minus the square root of 1 minus 2x all over x. Okay. Well, if we plug in 0 to where the x's are, then we'd have square root of 1 minus the square root of 1 over 0, which is 0 over 0. Can't have that now, can we? Huh. Oh, man. Okay, now... I hear singing. Why do I hear singing? Hold on. Huh. Must be our upstairs neighbor. Our upstairs neighbor is a little loud sometimes, but that's okay. It's during the day. They're probably just watching a movie. Okay. Derivative. Now, when we took the derivative, or the L'Hopital's rule of the one with the ln, we just left the ln on the outside. Can we do that here? I don't know if that's possible. It doesn't make sense that it would be. Let's write this in a little different way. So this is 1 plus 8x to the half power minus 1 minus 2x to the half power, right? I don't think that there's a way like, if we were to do this, 1 plus 8x minus 1 minus 2x, and then have like brackets, you know, and put all of that to the half power, that's not the same, is it? Because if it is, what's to stop me from solving this out? Because that would be 10x to the half power. You know, what's to stop me from doing that? Okay, I want to know. If we give x the value of just 1, then that's going to be the square root of 9 minus the square root of negative 1. We can't have that, can we? Because if we have the square root of negative 1, that would be an imaginary number. So maybe it's a good thing that I did it this way. But is this even possible? It doesn't seem like it should be. You know? It really doesn't. Okay, before let's just take the derivative of it in this form because that makes a lot more sense to me. Okay, and just so we know, the derivative of x is going to be 1, so it's just going to cancel out here in a second once we take the derivative, so that's why I wasn't really focusing on it. But this is going to be 1/2 times 1 plus 8x to the negative 1/2 minus 1/2 times 1 minus 2x to the negative 1/2. So this is going to be equivalent to 1 over 2 times 1 plus 8x to the half minus 1 over 2 times 1 minus 2x to the half power. Okay, and well, this is still the same thing. If we plug in if we plug in 1, we're plugging in 0, not 1. Why have I been thinking about plugging in 0? I mean 1. What's wrong with me? Intriguing. Okay, so if we plug in 0 here, you know, obviously that's 0. If we plug in 0 here, then that's going to be 2 times 1, so 1/2 minus 1/2. That equals 0. Maybe the answer is just 0. Maybe it is. Well, hold on. Maybe I should graph it. I'll graph it. Okay, we've got big ol' thingamajig, and then we take the square root of 1 plus 8x minus the square root of 1 minus 2x all over x. It did not work. Didn't show me anything. Well, maybe it did. Hold on. Let me standard. There's like 2 pixels right there. Zoom to fit. Holy cow. Okay, if we trace it, then we have it's non-existent at 0, and it's not existent after x equals anything above 0.5. I think, yeah, 0.51, 0.501. Yeah, 0.5 is the last domain. So it's like this. equal, yeah, 0 to 0.5 included. That's the entire domain of the function, which is interesting. I'm going to try 0. I'm going to plug that in, 0, submit. No, okay, that's wrong. They have a little video though, so I'm going to watch it.
Find the limit. Use L'Hopital's rule where appropriate. If there is a more elementary method, they might scope of different functions. So let's
Oh, I skipped a step. Did I? Yeah, I did. Okay. Erase, 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 erase. Okay, I hear Lion King. That's funny. Okay. The thing that I missed, let me get rid of this as well, is I should have used the chain rule and times it by the derivative of the inside function as well. So this is times 8 and this is times 2. So that's what I missed. Okay. So if we put 0 in here, then this is going to be inverse square root of 1, which is 1, obviously. So this is 1/2 times 8 minus 1/2 times 2. And so that equals 4 minus 1 equals 3. Let me try that. No, it still did not accept that. Okay, I'll keep watching the video. See what I'm doing wrong.
So 2x div 0 for x. To summarize, in order to find the limit,
Okay, they actually got 3 for their answer, but in the video they used different things. So since they used different numbers, then I should not have gotten 3. So I have to figure out, where did I go wrong? This would be 1/2 times u, which is the inside function, times u prime. Okay, so maybe I messed up somewhere in here. Okay, okay, let's pretend this doesn't exist. We'd have 1/2 times 1 over the square root of 1, right? And then we'd still be timesing it by 8 minus 1/2 times 1 over the square root of 1 times 2. So I'm not crazy because this and this just times in, it's just like timesing by 1, they just go away. So 8 divided by 2 is 4, and then you minus equals 3. Okay, but it did not accept the answer 3. So what's wrong? Is it because there's no x? Oh, what? Wait. What is... No. Okay. Yeah, because this becomes 0, that becomes 0. So it's just 1 over the square root of 1. I don't see where I went wrong on this one. I see it. Look at this. The derivative of negative 2x is still negative 2, not positive 2. That's what happened. So now that we know that, the that becomes a positive, and that number. Can anybody do it? Can anybody do it for me? 4 plus 1 equals 5. But I want to see, I feel like I answered 5 already, or was that a different, that was a different question. Okay, so 5. Submit. Woohoo! Big summer blowout. That one worked. 16. I'm gonna add more pages. Probably don't need that many. Just 2 more maybe. 16. We have the limit as x approaches 0 of tangent of 7x over sine of 4x. I guess I'm just struggling, like, how do I know when to use the chain rule and when not, when I'm using L'Hopital's thingamajig, you know? Not sure. But tangent of 0, not sure what that one is. Let me check. Tangent 0. I should just have this memorized. Okay, tangent of 0 is 0. So that's 0, and sine of 0 is 0. So no. Derivative of tangent. Oh, okay, I knew that. That's secant squared of 7x. And I'm wondering, should probably times it by 7 as well, huh? Yeah. And then on the bottom we have 4 times cosine of 4x. So that would be, let's see, what is secant? Secant, okay, we have cosine, sine, and tangent. Tangent is cotangent, or the inverse of sine is cosecant. So inverse of cosine is secant. So this is just 7 over cosine squared of 7x over whatchamacallit, 4 cosine 4x, right? And so in reality, this also equals 7 over cosine squared of 7x times 4 cosine of 4x. Okay, now let's simplify this, huh? Because, okay, I'm gonna put an arrow right here. So it's gonna be 7, that's a bad 7, 7, make it fancy, 7 over cosine of 0 is 1, obviously, right? Done that a million times. But what about cosine squared? Should still be 1. Interesting. I wonder why that made a difference. Hold on. Oh, because I I'm dummy. I'm a dummy. Okay, yeah, it's still 1. So that's just 1 on the bottom because it's 1. Oh, wait. That'd be 1 times 4 times 1. So that's equal to 7 over 4. Let's try that. 7 over 4. Hey, it worked. All right. Now we got 17. 17 is the limit as x approaches infinity of x times tangent of 3 over x. So as x approaches infinity, that goes out, and so this is just going to be infinity, right? And then this is approaching 0 as well, or not 0, but okay, it is approaching 0, this 3 over x, because as it approaches infinity it just gets smaller and smaller and smaller, never truly 0 but continually closer to 0. So that means what? Oh man. Let's express this as x times sine of 3x over cosine of 3x. Because for some reason my brain processes those better. I need water. All right. That probably equals, no, this equals infinity over infinity, maybe? Yeah, I'd probably say that. Yeah. Because let's see. Cosine of 3 over like 1000 is 0.999999. So I guess in its own way, cosine is approaching 1, but whatever. Okay, we're gonna move on. We're gonna draw an arrow, and we're gonna say we're just gonna take the derivative. That's what I'm saying. That's what I'm saying here. So x times cosine of 3 over x times the derivative of 3 over x. Oh my goodness, I don't want to do that. Okay. Let's put it up above in purple. So that's x. Whoa, that's a weird purple. X times the derivative of 3 plus, no, minus 3 times the derivative of x over x squared. So that's going to be 0 minus 3x prime over x squared. No. The derivative of x is 3. No, I mean 1. So that's just negative 3 over x squared. Do I have to do this? That's what I keep asking myself. Whenever something gets a little tough, I'm just like, do I have to? Do I have to though? Like, do I gotta? I guess that makes sense, because that'd be like doing the same as like 3 times x to the negative 1, you know? Times that, you get negative 3, and then you take another away. So it'd be 3 times x, negative 3 times x to the negative 2. Because it just keeps going lower and lower on that point. Yeah, that makes sense. I'll probably write it like that because that's a little easier. Or a little happier on my brain. Negative 3x to the negative 2. Plus sine of 3 over x times 1. Okay, and because we're doing the guy's rule, you know, what was his name? L'Hopital. Since we're doing his rule, his bottom piece will just be negative sine of 3 over x times negative 3x to the negative 2. Okay. Man. Let's simplify this. So if we times negative 3x to the negative 1 with x, that's going to be negative 3x to the negative 1 times cosine of 3 over x plus sine of 3 over x over positive, actually, 3x to the negative 2 interesting, actually. That's actually quite interesting. So it's interesting when you get a negative power on the denominator, because I'm not really sure if, like, should I just bring that to the top, you know, or should I just leave it? I'll probably just leave it. Sine of 3 over x. I guess to lessen the complications, we can simplify this a little bit more. And I'll do that by doing, so it's going to be negative 3 cosine of 3 over x. And then that's over x plus sine of 3 over x over 3 sine of 3x over x squared. So if we really wanted to get picky, we could simplify this a little bit more, but I don't feel like getting that complicated. No, it shouldn't be too hard. Stop being lazy, Hunter. Okay, this flips around, so this becomes negative 3x squared times cosine. Okay, I'm gonna say u equals 3 over x because I don't want to keep writing it. U plus wait. Okay. Yeah, plus x squared sine of u over 3x sine of u. Okay. Well, as x approaches infinity, you know, this is approaching infinity, then I think, well, hold on, we can divide out x here, can't we? Ah, man. Why do I keep making this more complicated on myself? Negative 3x cosine u plus x sine u over 3 sine u. Okay. Okay. All right. That's still 0 over 0, or, you know, 0 over 0, because sine x is approaching 0, you know, or it's approaching infinity, so technically this is infinity over 0, which, let me check my notes. my notes, I screenshotted something in here. Right here. No, I wrote it down. Okay, those are the only thingamajigs, but anyways, I think we need to get another derivative here, which I don't want to do, but I think it needs to be done. So, okay. Say negative 3x times the derivative of cosine, which is going to be negative sine u, and then add it to cosine u times negative 3, and then plus x times cosine u plus sine u times 1. Over over 3 cosine u. Oh, I probably need to times it by u as well. I don't want to do that. Or times it by u prime, I guess. So, okay. U prime equals what? What does u prime equal? I think we did that up here, right? That equals negative 3x to the negative 2. I don't really want to do that. But I have to. So u prime over there, and then u prime here, and u prime here. So if we times everything by u prime, well, yeah, then that becomes 9x to the negative 1, negative 9, because we have another negative here on the sign.